Hello, my name is Steve Miller. I'm a professor at Williams College, and this is the Coronavirus Lectures, sponsored in part by the Journal of Number Theory and the Teachers as Scholars program. I have had some issues with Zoom, and it does look like it is now allowing me to do the recording. Excellent. And so we had lost the pause button for a while. And so we're going to be talking about polynomials. So we're going to start off with lines and go to quadratics, which are degree 2, and talk about some applications. All right. So the goal is to learn how to solve polynomial equations.
Why did you use the soccer ball?
I thought it'd be fun, and I kind of like how the soccer ball seems to be coming out of the O. I thought it would
It's too big.
Too big.
That graph is like very uneven because of the 8 squared.
Right, and that's one of the. You know what degree this graph is? Do you think it's a line?
No.
No. Do you know what shape this
It's a
is?
curve.
Well, it's a special curve. It's a quadratic or a parabola. A quadratic is a degree 2. It has an x squared. So we're going to talk about those. A parabola is a name for the flight it is. And so there's a lot of things in life that have paths like this. So the flight paths of baseballs and cannonballs actually go like this. If an airplane all of a sudden were to lose its engines, it would have a path like this as well.
I mean, it would go up, start, and then lose its engine.
Right.
Like that's sort of how a plane goes. Like it goes up, stays up, and
Right.
then it starts to come down. But that's like
And then we're
less
going to do
speed.
other applications, and other applications to gambling and to the game of roulette, which we'll talk about. And then there's applications in cryptography. And today's lecture is going to be a short one. We're going to start with some simple things and build up. And so we're going to start simple today, get a little bit more advanced tomorrow, and then on the next day, see some applications. So the first one is linear equations. So what shapes are these?
Line.
And you can see in the name linear, here is line. Okay. So linear equations, we start with linear equations. So f of x is ax plus b, or we sometimes write y equals ax plus b. So here, x is the input, and f of x or y is the output. And so we have a rule, you give me an x, and I will tell you what y is. So for example, imagine we have the line y equals 3x plus 11, which is beautifully plotted over here. When x equals 2, how would we figure out what value of y we get? What would we do?
Plug it in.
Plug in. We have 3 times 2 plus 11. And what would that be? 17. 6 plus 11 is 17. And you can check if you look at this graph here, if you take 2, if you go all the way up, it does look like it's hitting 17. So here's my first question to you, right? Do you think that every straight line will cross the x-axis?
Yeah.
So don't answer yet. So think about this. So you got to be very careful. I'm going to pause the video. You want to be very careful about answering questions like this. I'm going to pause it in 3, 2, 1. All right, so we're back. So the equation y equals 3x plus 11, this does hit around,
-2.
looks like around -2, although I'm a little worried. Do we really expect it would hit around -2?
Yeah. Yeah, that makes sense.
It does?
Well, 9 is a multiple of 3.
It would be 3 times -2 would be -6.
Plus 11.
Right, and so that would not be
Okay.
y equals 0. So I actually don't think that
Yeah.
this is I don't think this is actually the line y equals 3x plus 11.
Yeah.
I think this is just a different line. And this line, it looks like it's hitting around -2. So what do these different things do? If I didn't have an 11 here, that just shifts the line up and down. The 3 here changes the slope. It changes how steep it is. And so almost every line will hit the axis. The only ones that won't is if I had y equals just 11. Then no matter what value of x you get, y would always be 11, and it wouldn't hit. So y equals 2, y equals 11, y equals 2020, anything like that will not hit the x-axis. So as long as a is not 0, it's going to cross the x-axis. And here's my next question to you. So we know if a is not 0, y equals ax plus b will hit the x-axis. Where will it hit? So for example, we could look at y equals 3x plus 11 and ask what value of x relates to 0, and how would you find that? Or more generally, how would you do y equals ax plus b and find where that hits? I'm going to pause the video for a moment. Okay, we're back. And so we're trying to find out where these lines will intersect. So for the first one, 3x plus 11, well, if we want that to hit the x-axis, y is supposed to be 0. So we get 3x plus 11 is 0. So we bring the 11 over to the other side, we get 3x equals -11. So x is equal to -11 thirds. And really, we could have just done, instead of using 3 and 11, we could just use A and B, and it's the same argument. We want AX plus B to be 0, so we get AX equals negative B, so X equals negative B over A. And now you can see why we want A to be non-zero. So why do we want A to be non-zero?
Because you can't divide things.
Because
by
we
zero.
can't divide things by 0. All right, so now imagine we know where a linear equation hits the x-axis. Does that uniquely determine the line, or could there be many lines that hit the x-axis in the same spot? So again, I'm going to pause the video and give you a chance to think about this question. All right, so what do you think the answer is to the question? Do you think that there's a unique answer? A unique line?
No.
No. So mathematicians like to see how to classify things. And so here's a bunch of lines that all go through the point 1. And what is the difference between these lines?
They have different slopes.
They have different slopes. They all have the same x-intercept. They all have different slopes.
Or y-intercept.
They have different y-intercepts, right?
Yeah, that's what I said.
Yep, but they have the same x-intercept.
It's kind of cool because I could like.
It's like
it's
this spiraling.
Yeah.
So how could we do this? We could actually factor. Imagine we have y equals ax plus b. I can pull the a out, and we're going to do this when we get to quadratics again. And we get y equals a x plus b over a. And so what is the root? When does this equal 0? Well, since a is not 0, this equals 0 when x plus b over a equals 0. So x is negative b over a.
Yeah.
So I can write down something of the form y equals a x minus 1, and that will go through the x-axis at 1, and the a will just change the different slope.
Yeah.
And so if I tell you the root, I don't quite know the line. I know it up to its slope. So 2 points.
Yeah.
So here we have the point 2, 1 and the point 3, 4. So what is the slope?
3.
3. It's the change in y divided by the change in x. So if we go over 1 unit for x, that's 3 minus 2. We go up 3 units for y, that's 4 minus 1. And so we get a slope of 3. So how do we get the equation of a line? Well, imagine you have some point here, some general point, we'll call it xy. So if xy is on the line, it has to give the same slope with the point 2, 1 as the point 3, 4 did. So y minus 1, the change in y, divided by x minus 2 must be 3. We cross multiply and we get y minus 1 is 3x minus 2, or y minus 1 is 3x minus 6, or y is equal to 3x minus 5. And so we now get our equation of the line. And so we see that here the y-intercept is negative 5, and this is where the line crosses the y-axis, and the slope is 3. We see this is a really nice way to write equations of lines. These give us a lot of information. So as I mentioned a little while ago, 2 points determine a line. If we know where a line crosses, that's almost knowing the line. It's not surprising that this shouldn't be the same, because with 2 points, we had 2 pieces of information. Here, we just have 1 piece of information. So we need 1 more bit of data, and that extra data is the slope. So in tomorrow's lecture, we're going to move on to quadratic equations. And so these are parabolas, and we're going to learn how to find where a parabola hits the x-axis. That is, if it hits the x-axis. Does every parabola hit the x-axis?
No.
That's something for you to think about for tomorrow. So I hope you enjoyed today's lecture. Have a great day. Good luck. Stay safe.